On problem 21, we want to find all the values of k that will make that factorable. So in other words, I want to know all the values that multiply to 14 and add to k. Well, really, let's look at all the ways we can multiply to 14. So I'll make a table here again. I'll go 1 and 14, and 2 and 7. And then 3 doesn't go into 14, nor does 4, is 5 or 6. Now, remember, k could be positive or it could be negative, so my sum could be 15 or 9. But remember, I could have negative 1 and negative 14, couldn't I? Or negative 2 and negative 7, because they multiply to 14. So I could have negative 15 or negative 9. So we'll say k equals plus or minus 9 plus or minus 15. Now if we slide over to question 22, we're going to do the same thing, except 2 times 12 is 24. So I'm going to list all the ways I can multiply to 24. And did I forget 1 on the previous one? Let me go back. No, I didn't. Good. Okay. So then 1 and 24, 2 and 12, 3 and 8, 4 and 6. So k could be plus or minus 1 plus 24 is 25. 2 plus 12 is 14. 3 plus 8 is 11. I'm going to rewrite that, I think. My 11 doesn't look very nice there. And 4 plus 6 is 10. I get positive or negative on each one of those. So that's what we'll do on that one. Now if we take a look at 23, now it's kind of backwards. I want to find all the numbers that actually add to negative 8. But multiply to something. And since k is 0, they either have to be both positive or both be negative. So if I start looking at the numbers that add to 8, or in this case, negative 8, that would be, let's start here, negative 1 and negative 7. Negative 2 and negative 6. Negative 3 and negative 5. And negative 4 and negative 4. So my value of k is going to be 7, 12, 8. Try that again. Not 8. 15 or 16. So I'm going to say k could be 7, 12, 15, or 16. So we have a lot going on there, don't we? Okay, now let's take a look at one with a number in front of it. So I know my two numbers have to multiply to 2k. And since k is 0, they both have to be, one positive, one negative, so they subtract to 5. Because I want a negative 5 in there. And so if I start thinking here, but I want k to be 0. So I take that back. They add to negative 5. So if I start looking at my numbers, I have negative 1. I don't know why I keep on putting next there, just muscle memory, I guess. Just want to make my table. I'll have negative 1 and negative 4. They add to negative 5. Negative 2 and negative 3. They add to negative 5. Well, then I get to 3. I go backwards, don't I? So my value of 2k, remember we're not doing k, it's 2k, is going to be negative 1 times negative 4 is 4 and 6. So 2k equals 4, which means k would equal 2. If I do 2k equals 6, divide by 2, k would equal 3. So my answer is 2 or 3 to make it factorable. Anything else, it would not be factorable. And if we take a look at number 25, well, based on what we've just been doing, hope you've seen that the size of B and C don't matter. It's more like the sign. So it could happen. So that's sometimes. So the absolute value B could be less than the absolute value of C, could be the same, it could be greater than. Because we're all looking at the factors, really. Now, if we take a look here, we have the square. And I want to find the perimeter. So first off, let's factor 9x squared plus 30xy plus 25y squared. So multiply first and last. So what we get here is 9 times 25. So 9 times 25 is 225. And I want it to add to 30. Well, since it's going to be a square, I know it's going to be the same. So that would be 15 and 15, wouldn't it? So we're going to say, I'll write this as 9x squared plus 15xy plus 15xy plus 25y squared. Well, if I look at my first two, 3x goes into both of those. So we'll go 3x. And I did it again. Let's try 3x times 3x plus 5y. If I look at my next two, 15 and 25, 5y goes into both of them. And I'll get 3x plus 5y. So in other words, it's 3x plus 5y for the length. The width is 3x plus 5y. Now to find the perimeter, I'm going to add them up. So my perimeter is going to be 3x plus 5y plus 3x plus 5y. So I get 6x plus 10y for the perimeter, and that will be in inches because they do have units on this one. And units are kind of an afterthought with the polynomials, but if they're there, we should include them.